Welcome to the next lecture from Introductory Statistics. And we will proceed now to a very important part, a very essential part in simple probability, which is called Bayes' theorem. As I mentioned with an example in the previous lecture, this is the direction we were moving towards, right? So, what are the things that we need to know when we are talking about Bayes' theorem? Well, Bayes' theorem is associated to the computation of a posterior probability, posterior as in order which comes later, probability of the event, conditional event, AJ, conditioned to be from a given prior probability, something that has already happened, which is probability of AJ. AJ event has already happened, and conditional probabilities like B conditioned to AJ. This is very, very important when it comes to elementary probability. A lot of conditional events probability has to be calculated using this. And how do you find it out? As you must have noticed in the previous lecture, we were actually just using multiplication rule that we had learned, right? So it's a simple application of multiplication rule which has a name to it because, this application is associated to Reverend Thomas Bayes around in the 18th century. So that's why we call it Bayes' theorem. When we are getting into Bayes' theorem, things that are important term and concept. First important term, mutually exclusive. As a lot of us already know, what is mutually exclusive? When two events do not have anything in common. Or, in other words, they are disjoint. So, AI intersection AJ is equal to phi. Therefore, probability AI intersection AJ is equal to 0 for all i's not equal to j. Okay. Then comes another very important term, which is exhaustive. When will we call events exhaustive? Well, in case you have events like A1, A2, so on and so forth till AK. And what you realize is that if you take the union of all these events, it turns out to be same as the entire sample space, which I'm quoting as S here. So if the union of all the events, possible events, outcomes that are coming in the events is equal to the sample space, then we say that these events are exhaustive events. Now, the third important concept here is the law of total probability, something that we have already applied in the previous lecture, but now formally. What is the law of total probability? Suppose you have events A1, A2, so on and so forth till AK, and they are mutually exclusive and exhaustive. So what does it mean? It means that AI intersection AJ is equal to phi for all I not equal to j, and the union A1 union A2 till AK is equal to the entire sample space. There is nothing apart from this in the sample space. Then for any other event B, suppose now some event B occurs. Probability B. Now B is an event that is happening in this experiment itself, associated to this sample space itself. Okay. Now this event B is happening, and B is an event which is happening later, posterior, and A1, A2, so on and so forth. These are the events that have already happened. Now, B, occurrence of B is dependent on occurrence of A1 also. Occurrence of B can be dependent on the occurrence of A2 because all these have already occurred. Therefore, the probability associated to occurrence of B is equal to probability B occurs given A1 has already occurred multiplied by probability A1 occurs plus probability B occurs given A2 has already occurred multiplied by probability A2 occurs plus so on and so forth till AK because we have k such events which have already occurred. Now, why do we get this? How is this happening? How is probability B the summation of the probability B condition to AJ multiplied by probability AJ, where J can take values 1 to K? Why? This is the question you must ask yourself. Now, I'll give you a picture and then we will put it into words. Let's look at this picture. Suppose there were 4 events that have already happened, A1, A2, A3, A4, okay? Now, this is your sample space, the entire sample space, and in here, can you observe that A1, A2, A3, A4, these are mutually exclusive and exhaustive. You don't have anything in common, and all 4 of them are creating the entire sample space. So one thing clear, that our assumption is being satisfied. Now, if you observe, this is event B that has suddenly occurred. So this is the event B that has suddenly occurred. Let me shade it like this, okay? Now, can you see an association here of B with A1, A2, A3, A4, right? So therefore, if I, in terms of set theory, look into it, I can say that B is basically A1 intersection B union A2 intersection B union A3 intersection B union A4 intersection B, right? It has an intersection with all, okay? Now, in terms of probability, if you will look into it, try to understand, because A1, A2, A3, A4 are exclusive, mutually exclusive. So these intersections are also mutually exclusive. They don't have anything in common, okay? So therefore, probability of B is nothing but probability of A1 intersection B plus probability A2 intersection B plus probability A3 intersection B plus probability A4 intersection B, right? Now these intersections are something that we can figure out using the multiplication rule. So probability B is equal to probability A intersection B is nothing but probability B condition to A1 multiplied by probability A1 plus probability B condition to A2 multiplied by probability A2 plus probability B condition to A3 multiplied by probability A3 plus probability B condition to A4 multiplied by probability of A4. So कहने का मतलब सिर्फ ये है, देखो कि B जो है ना, वो A1 से भी एसोसिएटेड है, A2 से भी है, A3 से भी है, A4 से है, राइट? तो वो B जो है, occurrence of B can happen जब A1 हुआ है, A2 भी हुआ है, A3, A4 सबसे एसोसिएटेड है, तो therefore comes into picture. को कभी भी हमेशा याद रखिएगा, टोटल प्रोबेबिलिटी का नोशन कब आता है पिक्चर में? When do you start thinking about total probability? जब कोई एक चीज, जैसे फॉर एग्जाम्पल वी आर टॉकिंग अबाउट से प्रोबेबिलिटी ऑफ स्मोकर. अब स्मोकर कुड बी मेल ऑल्सो, स्मोकर कुड बी फीमेल ऑल्सो, राइट? So therefore, being a smoker is dependent on being a female, male, क्योंकि दोनों हो सकते हैं, राइट? तो अगर मान लीजिए मुझे प्रोबेबिलिटी ऑफ अ स्मोकर निकालना है और मुझे मेल फीमेल में डिवाइडेड डेटा दिया हुआ है, तो मैं बोलूंगी दैट प्रोबेबिलिटी ऑफ अ स्मोकर डिपेंड्स ऑन मेल एंड डिपेंड्स ऑन द प्रोबेबिलिटी कि कितने मेल्स हैं, ओके? इसी तरीके से डिपेंड्स ऑन फीमेल एंड डिपेंड्स ऑन कितनी फीमेल्स हैं उस डेटा सेट में, ओके? So suppose that is given to you, you will be able to find the probability of being a smoker. If you've selected someone, that person is a smoker, depends on male, female. ये एक एग्जाम्पल है, सिंपल एग्जाम्पल सोचने के लिए. कहने का इतना ही तात्पर्य है कि कभी भी कोई इवेंट अगर हो रहा है और वो पहले कुछ इवेंट्स पे डिपेंड करता है, देयर कम्स द नोशन ऑफ टोटल प्रोबेबिलिटी. और अब इसके साथ आगे आता है बेस थ्योरम. Once the concept of total probability is clear, the next thing that comes in line is Bayes' theorem. Now, Bayes' theorem is basically a scenario where you are trying to find out a conditional probability wherein you will be associating the concept of total probability. Formally speaking, Bayes' theorem essentially is this scenario. Let A1, A2 till AK be a collection of K mutually exclusive and exhaustive events with prior probabilities, probability AI given to us. So probability A1, probability A2, these events have occurred. So we have that associated probability with us. Now suppose some other event B occurs. Then for any other event B for which probability B is strictly greater than 0, it should not be equal to 0. The posterior probability, because see, posterior probability मतलब बाद में अगर मैं probability निकाल रही, posterior probability of AJ given this additional information that event B has occurred. This is, now understand this, that it's a conditional probability. Probability of AJ given B has occurred. Now, this will be equal to probability AJ intersection B upon probability B. Now, A1, A2, A3, so on and so forth, these are the events which have occurred. उन इवेंट्स के होने के बाद वी आर टेकिंग एन इवेंट बी, जो कि हमने अब टोटल प्रोबेबिलिटी कॉन्सेप्ट पे सीखा. तो बी जो है कैन बी एसोसिएटेड टू A1. बी इज हैपनिंग, इट कुड बी डिपेंडेंट ऑन A1, A2, A3 and so on and so forth. So therefore comes the concept of multiplication rule and total probability. ये जो intersection है कहाँ से आएगी? This is nothing but multiplication rule. So probability B conditioned to AJ multiplied by probability of AJ. And what you see in the denominator is probability B, which is the total probability of B given AJ into probability AJ, where J goes from 1 to K, क्योंकि हमने K events लिए हैं यहाँ पे. This is what is Bayes' theorem. So what is happening? Bayes' theorem is nothing but posterior probability. We are calculating posterior probability in which we will have to use the concept of multiplication rule and total probability. तो जहां पर भी ऐसा सिनेरियो आए कि ये जो आपको डिनोमिनेटर में दिख रहा है, ये डिनोमिनेटर की जो प्रोबेबिलिटी है, इट इज टोटल प्रोबेबिलिटी अंडर सर्टेन सर्कमस्टेंस, देन ये जो प्रोबेबिलिटी आप निकाल रहे हैं ये बेस थ्योरम है, नथिंग एल्स. I always tell my students to remember Bayes' theorem from the point of view of a scenario wherein this event B, wherein you're trying to find out a conditional probability AJ given B, and this event B is something which is associated to different events A1, A2, A3. So the probability of B would be dependent on all these events. Therefore, I'll have to use total probability. The moment I'm using total probability, that means I'm actually, this conditional probability that I'm figuring out is nothing but Bayes' theorem. I hope it is clear to you how to use the multiplication rule and total probability, and with which how to figure out whether I'm supposed to use Bayes' theorem or not. In the next video, we'll work on certain examples and it will be absolutely clear to you where to use Bayes theorem and where we do not need to use Bayes theorem. Thank you very much.